In our previous videos, we learned how to solve systems of equations using two methods. First, by graphing. Second, by substitution. And today we're doing the third method called the elimination method. For this video tutorial to be effective, I will be using this format. First, I will flash each question for about 10 seconds, and you may pause the video whenever you want to give yourself time to try out each question. And finally, I will explain each question and I'll give you some tips and strategies on how to solve each question. Are you ready? Here we go. In doing elimination method, we need to write first the equations in the standard form ax plus by equals c. And here, a, b, and c must be integers. Question number 1. Find the solution of the system negative 4x plus y equals negative 19 and 4x plus 5y is equal to 1. The first thing that you need to do is to inspect the coefficients for x and the coefficients of y. In this system of equation, the coefficients of x are negative 4 and positive 4. Since the coefficients of x are negative 4 and positive 4, we need to do addition to eliminate the variable x. So now we're adding the systems of equations. Negative 4x plus 4x, this becomes 0x. Then we have 1y plus 5y, that is 6y, is equal to negative 19 plus 1 is negative 18. Now divide both sides by 6. So y is equal to negative 3. Solving for x, we can substitute y equals negative 3 either to the first or second equation. It should give you the same value for the x. I will choose the second equation because I have smaller numbers. So now we have 4x plus 5. Instead of y, I will replace that with negative 3 is equal to positive 1. Solving for x, we now have 4x. 5 times negative 3 is negative 15 is equal to 1. Now we do the inverse operations. Plus 15 to both sides. Then we have 4x is equal to negative 15 and 15 is 0. 1 and 15 is 16. Dividing both sides by 4. So x now is equal to 4. So in this system of equation, the solution is positive 4, negative 3. Always write the answers as ordered pair, beginning with the x-coordinate 4 and the y-coordinate negative 3. To check your answer, we can plug in 4 negative 3 to both first and second equation, and it should be true for both equations. So let's substitute for negative 3 to the first equation. We have negative 4 times the x value positive 4 plus negative 3 is it equal to negative 19. So here we have negative 16 plus negative 3 is equal to negative 19. And yes, it is true, negative 19 is equal to negative 19. We also have to check for negative 3 with the second equation. So we have 4 times 4 plus 5 times negative 3 is it equal to 1. So we have 16 plus negative 15 is equal to 1. And 1 is equal to 1. So it is true for both equations. Question number 2. Find the solution of the system negative 7x plus 10y equals 5 and negative 5x plus 10y equals negative 5. So in this problem, the coefficients of y are both positive 10. So for we to eliminate the y, we can't do addition because that will not be equal to 0. What we need to do here is minus or subtraction. So now let's subtract the second equation from the first equation. Always be careful in dealing with negative numbers. Negative 7 minus negative 5 is negative 2x. 10y minus 10y is 0, so y variable is eliminated, is equal to 5 minus negative 5, that becomes 10. Next, we can divide both sides by negative 2. So this means our x value is negative 5. Now let's solve for the y. I will use the first equation. So we have negative 7 times our x is negative 5 plus 10y is equal to 5. Negative 7 times negative 5 is positive 35 plus 10y is equal to 5. Now we can subtract 35 to both sides. And we have 10y is equal to 5 minus 35 is negative 30. Now dividing both sides by 10, so y value is negative 3. So the solution for this system is negative 5, the x-coordinate, and negative 3, that's your y-coordinate. So when you graph this system of equations, they will cross at negative 5, negative 3. Question number 3. Find the solution of this system. For question number 3, the coefficients of x are not the same. Coefficients of y are also not the same, unlike with questions 1 and 2. So for this question number 3, we need to do multiplication first before we can eliminate. So you need to make a decision here whether you want the x coefficient to be the same or the y coefficient to be the same. In this example number 3, the easiest way to do it is to make the y coefficients the same. Because if we have 1 and 8, this means that you can multiply the first equation to make the y coefficients the same. So if I have here negative 8, what will I multiply with the first equation to make it also 8? So we can multiply the first equation by 8. Make sure you multiply each of the term by 8. So now we need to rewrite the first equation. 7x becomes 56x, because 7x times 8, minus 8y becomes minus 8y, and negative 30 becomes negative 240. Now I will just copy the negative 10x minus 8y is equal to 24. Now we need to subtract the second equation from the first equation to eliminate the variable y. 56x minus negative 10x is 66x. Negative 8y minus negative 8y, that becomes 0, eliminated, is equal to negative 240 minus 24 is negative 264. Now we can divide both sides by 66. So x value is equal to negative 4. Now let's solve for y. I will be using the first equation 7x minus y equals negative 30 to solve for the y value. So we have 7 times negative 4 minus y is equal to negative 30. This equation is the same thing as negative 28 minus y is equal to negative 30. Adding 28 to both sides, we have negative y is equal to negative 2. Now dividing both sides by negative 1, or multiplying both sides by negative 1, your y value now here is positive 2. So the answer for this system is negative 4, positive 2. Again, x coordinate followed by the y coordinate. Question number 4. Find the solution of the system below. Did you notice anything with the system of equation? The x coefficients and y coefficients are 7 and negative 7. Now let's add the systems of equations and see what will happen to the variables x and y. What is 7x plus negative 7x? That's 0x, right? 7y plus negative 7y is also 0. So this means the left side here is 0. What about the right side? Negative 25 plus 28 is equal to 3. And this is not a true equation. Since we ended up having a false equation, this means that this system will have no solution. Meaning, when you graph the lines, the system will be parallel lines. If you came up with 0 equals 0, then that means there's infinite solution, because that will be a true equation. Question number 5. The first equation is in standard form, but for question 2, it's not in standard form yet. So for the second equation, we need to rewrite it first in standard form. So to do that, I will multiply the second equation first by 5. So when we multiply 8/5 by 5, that's 8. So we have 8x is equal to negative y times 5 is negative 5y. 1 times 5 is 5. And transferring negative 5y to the left, this is the same thing as 8x plus 5y is equal to positive 5. So now, the system of equation is the same thing as negative 10x plus 16y is equal to 16. That's the first. And the second is 8x plus 5y is equal to 5. And in this system, we cannot add or subtract right away. The x coefficients are different. The y coefficients are also different. So this means that we need to multiply the equations to make the coefficients the same. To make the x coefficients the same, I will multiply the first equation by 4 and the second equation by 5. That way, the first equation becomes negative 40x plus 64y is equal to 64. The second equation will be 40x plus 25y is equal to 25. Now we can do addition method. Negative 40x plus 40x is 0. 64 plus 25 is 89, so we have 89y. 64 plus 25 is 89. So dividing both sides by 89, y is equal to 1. I will use the first equation to solve for x. We have negative 10x plus 16 times 1 is equal to 16. So this is now negative 10x plus 16 is equal to 16. Subtracting 16 to both sides, we have negative 10x is equal to 0. So this means x is equal to 0. The solution for this system is 0, 1. Are the answers.